Example 3. Find values of variables. Use the figure to find the indicated variable. Explain your reasoning. So this is one of those problems where I have to pay attention to what the problem wants. Does it want the whole angle, or does it just want the variable, or does it want both? Here it just wants the variable, so I know what I'm going to do and what I'm looking for at the end is I'm looking for what x equals. I can even write that up, have a box ready to go, and I know I'm just going to plug some number into that when I'm all done. So let's talk about the relationships here. So we're looking at measure of angle 4, and we've got some sort of expression for it, 2x minus 17. And we're looking at angle 1, which is just 85. Now, looking at these two angles, there is no direct relationship. They're on alternate sides, and one's on the interior and one's on the exterior. We don't have a name for that. So we're going to have to make some sort of transitive property leap of logic. Now, let's think about angle 1. What does angle 1 correspond to? So it's on the top left of this picture. Angle 7 is on the top left of the bottom part of the intersection. So that tells me angle 1 is congruent to angle 7. Which is nice because angle 7 and 4 are right next to each other. So I'm going to say that that's corresponding angles. So that's me explaining my reasoning. And now that I know that those two things are congruent, I know that the measure of angle 7 plus the measure of angle 4 should add up to be 180 because they form a linear pair. So now I've justified that argument there. Now I just substitute everything in. Angle 7 is the same as angle 1, so it's 85. Angle 4 is 2x minus 17. 2x minus 17 equals 180. Now I just have an equation to solve. 85 minus 17 is 68, so I have 2x equals 68. 2x plus 68 equals 180. I subtract 68 from both sides, and I get, I'll write it over here, 2x equals 112. Divide both sides by 2, I get x equals 56. And there's my answer. Now notice when I was doing this, I justified my geometry, but I didn't justify the steps of algebra. Once you get it down to algebra, you can skip that part of justifying each step. I know you know how to simplify. I know you know how to add things to both sides or divide things on both sides. Those I'm not too worried about. It's the geometry parts I want you to explain your reasoning for. All right. Now, I'm going to erase this stuff here because I've got a new set of information that I want to use. And that's one good thing to practice. The pieces may be correlating to each other, but here you can see on the second problem we're solving for y, which is a completely different variable, so we don't want to use any of the old stuff from the last problem. So I'm going to clean my slate and start over again. So we're looking for y, and we've got angle 3 and angle 7. Angle 3 is 4y, 4y plus 30, and angle 7 is 7y plus 6. Now we just need to identify it and see if there's any sort of relationship between angles 3 and 7. And I see they're on alternate sides of the transversal, and they're on the interior, so angle 3 is going to be congruent to angle 7 because they are alternate interior angles, which means their measures are the same. So all I have to do is write down the expressions that represent the measures. And now I solve. Subtract 4y from both sides. 30 equals 3y plus 6. Subtract 6 from both sides. 24 equals 3y. Divide by 8. Divide by 8. And you get y equals 3. And there is my solution. Remember, on these ones, it's really about justifying the geometry part, making sure that you can recognize when you're using corresponding angles or alternate interior or vertical angles or vertical pairs. You just want to make sure you're recognizing which of the relationships you're using to make the jumps, the transitive jumps between the equalities.